Hey, welcome. Today we're looking at 7.5 sum and difference formulas. Our formulas are here. We have one for cosine, sine, and tangent. One thing to note before we begin is that the plus and minus symbols inside here, all they did was, instead of making 6 different ones, they did 3. And in order for us to do this properly, we follow the arrows or follow the signs. So if we're doing plus cosine alpha plus beta, then we follow the top. So it'd be cosine alpha cosine beta minus sine alpha sine beta. Now, likewise, if we're doing a subtraction, cosine alpha minus beta, then we would be following the bottom one. So there would be a plus in our formula. So just make sure that we understand, if we're using the top one, we follow the top. If we're using the bottom one, we're following the bottom, and we should be good. So the first example is asking us find the exact value of cosine 75 degrees. Now, when it's asking us to find the exact value, that means that we should be getting the numbers from the unit circle. We shouldn't be coming out with a decimal in the end. The only problem is that 75 degrees is not one of the angles that's on a unit circle. So one of the uses of our sum and difference formula is we can say, all right, we don't have 75, but what we do have is we have 45 and 30. And if we add those two together, we get 75 degrees. All right, so we're going to follow our cosine. Maybe change colors here. So we're doing cosine 45 plus 30 is equal to, and then we're going to start filling in our stuff here. So if you want to, then we can label these. 45 will be our alpha, 30 will be our beta, and then we're going to start filling in to our formula. So we have cosine alpha, which is 45 degrees, times cosine beta, which is 30 degrees. And then remember, since we're adding the 45 and 30 to get 75, then we have to follow the top again. We're going to have a minus in between. Oops. Sine alpha, which is 45, times sine beta, which is 30. All right, from here we're going to start filling in our values. Cosine 45 degrees is radical 2 over 2. Cosine of 30 is radical 3 over 2. Minus sine 45 is radical 2 over 2. And sine 30 is a half. All right, so those values are directly from your unit circle. And then we're going to simplify this a little bit. Square root of 2 times square root of 3 on top is going to be square root 6 over 2 times 2, which is 4. Minus square root of 2 times 1 is square root 2 over 2 times 2 is 4. Okay, and we're done. In the book, you might see it as combine over one denominator. Either way is fine. Okay, so let's recap right here. Step 1, find the angles that either add or subtract to get 75. Right, so we said 45 and 30 add to get 75. You could have done a subtraction. You could have said 120 minus 45, in which case we just use the subtraction version of our cosine. Step 2, fill in the formula with our alpha and beta. Step 3, substitute the values from the unit circle unit circle. And then step 4 is simplify. So that's pretty much what we're going to be doing today. Okay, so let's find 2 more. This time we're doing sine and cosine. These are both in radians. Radians might be a little bit harder to work with for those of us who are not familiar with fractions. Maybe I can give you a breakdown over here. So these are the angles in the first quadrant at least. So let's do pi over 6 is equal to 2 pi over 12. Right, so all we did was multiply the top and bottom by 2 to get it to 12ths. Pi over 4 is 3 pi over 12. Pi over 3 is 4 pi over 12. And pi over 2 is 6 pi over 12. So what we're trying to do here is we're trying to find 2 numbers that, well, we can't add these numbers to get 1 pi over 12, but we can definitely subtract. So I'm going to subtract these 2. You could definitely do another combination if you could find one, like pi over 3 and pi over 4. If we subtract those, you also get 1 pi over 12. But let's follow the steps. So I'm going to say sine, and I'm doing 3 pi over 12. Well, let's not put 3 pi over 12. Let's put pi over 4 minus pi over 6. And the reason I'm doing it like this is because we're going to have to grab those values for our sines and cosines when we start filling it in. Referring back to our formula, now we're doing a sine and we're doing a subtraction. So we got to follow the bottom. We're going to have a subtraction again. So we're going to have sine alpha cosine beta minus cosine alpha sine beta minus cosine alpha sine beta. Okay, sine pi over 4, radical 2 over 2. Cosine pi over 6 is going to be radical 3 over 2. Notice we're coming up with the same values again because we're using numbers taken from the unit circle. Cosine pi over 4 is radical 2 over 2. Sine pi over 6 is a half. Radical 2 times radical 3 is radical 6 over 4 minus radical 2 over 4. And we're done. Okay, let's do the same thing with cosine 7 pi over 12. I know that I can add these 2, right? 3 pi over 12 plus 4 pi over 12 is going to give us the 7 pi over 12. So let's rewrite this. Cosine pi over 4 plus pi over 3. And then when we put this together, we have sine alpha sine beta. Whoops. We're doing a cosine again. Cosine alpha cosine beta minus, right? Because we're adding. Follow the top. So cosine alpha cosine beta minus sine alpha sine, sorry I'm running out of room, beta. And then we fill in our values. Radical 2 over 2. Cosine, there's going to be 1/2. Cosine pi over 3 is 1/2. Minus sine pi over 4. Radical 2 over 2 times radical 3 over 2. And then when we simplify, so again, you see that we're coming out with the same numbers because we're using similar, we're using the same values from the unit circle over and over again. All right, so for this one, it's asking us to find the exact value. So what we're doing here is we're actually working backwards. All right, so we're trying to find the one that has sine, cosine, minus cosine, sine. Sine, cosine, minus cosine, sine is this one. The minus is on the bottom, so it's got to be a minus. So we're doing sine alpha minus beta. Oops. So sine alpha minus beta. So sine 80 minus 20 degrees is going to be the sine 60 degrees. And wait, we have a sine for 60 degrees. The sine at 60 degrees is radical 3 over 2. Okay, and the last one, we're going to do the tangent, 5 pi over 12. So I know that's the same thing as 2 pi over 12 plus 3 pi over 12. This is going to be pi over 3 and pi over 6. Oops, sorry, pi over 4. I'm reducing fractions around. Okay. So now we're filling in the tangent formula, which is, if we go back here, tangent, we're doing plus, right? So we got to follow the top and the top. So tangent alpha tangent beta over 1, oops, sorry, this is a, let's go back, it's not a times, that's a plus, it's a plus 1 minus tangent alpha tangent beta. Now the nice thing about this is on the unit circle at pi over 4, the tangent is going to be radical 2 over 2 over radical 2 over 2. Anything divided by itself is going to be 1. So I know that the tangent of pi over 4 is going to be 1. So I can start filling that in already. Now tangent pi over 6. Our opposite, our y value is a half over radical 3 over 2. Kind of running out of room here. But let's find some room over here. So we know anytime we have a complex fraction, we can rewrite it as the numerator times the reciprocal of the denominator, which is the 2's cancel, 1 over radical 3. Now we want to rationalize this, right? We don't want that square root in the denominator, and we can do that pretty easily. We're going to multiply by the denominator top and bottom. So we get radical 3 over square root 3 times square root of 3 is square root of 9, which ends up being 3. So we have radical 3 over 3, radical 3 over 3, and then we're done. Technically, you can rewrite this because we have 1 times over there. So if we want to simplify it as much as possible, Then we have radical 3 over 3 plus 1 over 1 minus radical 3 over 3. Okay, and we're done. Alright, so make sure if you have any questions that you write them down. Come to class, we can work on it if you do need some help. Good job today.